Hello dear students, this is MSc Electronics final year course paper 7. We are going to now onward discuss and the remaining lectures where we left last time. This is the first topic we are starting with. We left, if you remember, the last time was the feedback oscillators. The section was the feedback. We did completed that, and the oscillators were remain to be started. So this is the first section, and it is ELEC-OSC-S1A electronics oscillator section S1A. So in today's lecture we are going to discuss the basic working principle of an oscillator. What is an oscillator? An oscillator, actually, it is an electronic circuit which converts DC electrical energy to AC electrical energy. In fact, the basic working principle is that there is an exchange of oscillations of electrical energy between the capacitor and inductor C and L. In this slide, we are going to explain the detailed process of the conversion of the DC into AC. We will be taking into account the AC signal which is generated by this we are normally also called the LC tank circuit. Tank means it's almost a block, look like a tank. So there's a one circuit involved, but I have done, I have divided this slide into 8 the duplicate circuits, where I will explain that whole cycle starting from the origin A. We took that A, going from the one positive half to the other negative half will be generated by this circuitry. So in this figure 1, this is the AC induced voltage which is taken across the inductor, that will be taken as induced voltage VI, and this is the theta sine omega t. Since sinusoidal wave function, so say V naught, or V naught is the maximum amplitude, V naught sine omega t, so r sine theta, V naught sine theta. So let's start with if you take that output here, initially what we do, we supply DC voltage to this LC tank circuit. What happens that capacitor is initially empty and it offers a zero reactance. The plates are empty, so they offer the zero impedance or zero reactance, and all the DC voltage exponentially charge this capacitor to its peak value. So once it is charged to peak value, that during the charging till the capacitor is charged, the output is VA, and that is equal to 0. You can see here the A point is a 0 voltage. Once it is completely charged, then this inductive reactance, now it has the at the complete charging, means the infinite resistance being offered for a DC by the capacitor. So while the other arm of this LC tank circuit has the inductance which now has a low reactance, so this charge will now discharge through this inductor reactance and along with the ohmic some resistance as well. So in the you can see the gradually the charge is being released from this plate and going to the passing through the coil. Now this now this charge is exponential, you know, it's not linear. So there is a, you can see the expanding magnetic field is observed over here. So it is a point VI, which is B, point B here. So this is the now induced voltage is being experienced at the output from A to B. So VB is taken on the graph of the output AC voltage. Now DC is being converted into AC because of this expanding magnetic field, which is causing the induced EMF, induced voltage, and the VB. Here in the slide C, rather the figure C, you can see the capacitor is completely drained, completely discharged. So while the coil has the maximum expanded magnetic field, and you can see over here, which is pointing to the VC, this is the peak value, while in the next slide, next figure D, what we see that now the field collapses. Now magnetic field collapses. Now this collapsing magnetic field now in the opposite direction, you can see that we will be seeing that collapsing will cause the current, the field will cause the induced current now in the opposite direction, and the empty capacitor will start being charged with a negative charge and the positive other plate, other side, and this is given by the VD. So gradually what will happen that it will completely charge and the field will completely collapse. The VE point will reach, again we see this is the point. Let me take, if I can take the picture. Okay, I will move along with that. We'll put it over here so we can see. Okay, again I lost it. Okay, so let me, okay, so it is VE now, as we have already shown that. So similarly, now capacitor completely charged but with opposite polarity. It will start again discharging, but now this time in the opposite direction. So the current will flow in the opposite, and the magnetic field will be now in the opposite to the previous one. Okay, this is this direction, the other one is this direction. Suppose we take this one. So now this is expanding magnetic field, which is VF. Now let me see again, this is the VF. Now this is a negative potential, the negative cycle is being generated because of the reverse magnetic field and reverse the north and south poles, and so on and so forth. Here again the capacitor is discharged, and here we can see this field is maximum expanded but in negative direction, which is VG. Again we can see the VG point is there, negative side, and again it collapses, but this time it collapses, the capacitor is empty. The collapsing field is now in the same direction as initially we have. It is collapsing back, so it will be VH, so it will charge the capacitor to the VH and go back to the A position, which is A is the initial position. You can see 0 means the capacitor will fully charge with the positive. At the same time, from the outside the voltage comes in and also charge the capacitor, and it gives us the complete one cycle. So that's all the process of that. Now let's see a very beautiful animation we have got here. This is the explaining the exchange of the flow of the energy. So here we have the capacitor. You can see the capacitor. In this case, the polarity has been taken. The credit goes to the YouTube All American 5 video. You can see these animations over there as well. But in this animations, the negative side is taken this time. I took the positive one, but it doesn't matter. So this negatively completely full charge, the capacitor is drained. Now the this electron movement shows that going through discharge through the coil, and you see the expanding magnetic field occurs. So again the capacitor is discharging, and expanding is because the capacitor discharges exponentially, charges exponentially, charging discharging takes place exponentially, which causes the variable varying. This DC energy is now varying in current passing through the coil, which is causing this expanding magnetic field. Now here the magnetic field is completely expanded and the capacitor is empty. Now it will start collapsing, but in this case, now in the collapsing, you can see it is now inducing the current inside, which is now causing the capacitor to charge in the opposite polarity, the positive now this plates and the negative other side, and the capacitor is is getting charged and the coil is getting discharged or the collapsed. The completely collapsed magnetic field will cause, you will see the maximum charge capacitor. Now the polarity will remain the same. The capacitor is charged. Now it will again discharge, but this time the direction remains the same, and it will cause again the expanding magnetic field, and so on. This process takes place, expanding, still expanding, and see the maximum expanded magnetic field. Now in this process, we can see that the charge and discharge is taking place. In this quick view, you can see expanding and collapsing magnetic fields are being generated. And further, if we move, you see this is actually the exchange of energy taking place, plus minus between the two. It does not go on indefinitely. Of course, there is a damping, the resistive effects are there. The actual signal is not pure sinusoidal, it is damped oscillations, which are then supplemented by the feedback. Now you see again, now this slide, the next animation is about the AC signal cycle, which is being will be here in a moment. Here we see the positive first discharge is causing expanding magnetic field, which is the induced field, and AC cycle is being here generated, positive off. In the collapsing will cause the reduction in the induced voltage here, but over there the charging in the capacitor, and then goes to 0. It is completely charged. Now the discharge will take place from this side, which will cause again the expanding magnetic field, but now in the opposite direction to the previous one. So this AC cycle is also being explained over here, how this DC energy is causing the AC cycle. In the oscillators or UPS we have got in our homes, that uses the same principle. But remember, this is LC tank circuit. Okay, there are other types of oscillators as well, piezo oscillators, other type of there, but this one is the particular the LC tank circuit. So you can see in a quick motion the expansion and the collapsing of the field is causing. Now this is the AC cycle, ideal cycle, which we expect, but this is not the case, because we expect this kind of the cycle to be generated. Actually what happens, this is the damped oscillation, because of there's a damping, there's a resistive to and fro oscillations will die within few 2-3 oscillation cycles. So what happens that a feedback is provided from the oscillator. You know, we have explained that in the feedback oscillator, small portion from the output of amplifier is fed back to the input. So that feedback causes the sustained sinusoidal oscillations. So it's a beautiful animations. I hope it will help you in understanding this phenomena of the oscillator. With this, we reach to the end of this talk. See you next time in next new topic. Thank you.